my name is Miss Valentine, and I am a kindergarten teacher at Adrian Burnett. This is our science kindergarten lesson. It is activity 4. Activities and handouts can be found under the Student Resources tab on the Knox County Schools website. Also, we would love for you to show us what you've learned. We'd love for you to tweet out at KCS Science. Now, if this video is hard for you to understand, you can turn on closed captions if available. You can adjust the playback speed to slow down the video. You can also consider watching short clips, then pause, listen, and watch again, or you can go find someone in your home to watch the video with you. You can stop frequently, talk to your partner about what you heard and what you understood. Now, last week's science lesson, Miss Jones talked about solids, liquids, and gases. I want you to share right now with that someone at your house what you remember. I think that I heard some of you saying that a solid does not change its shape. You're right. I have a table, and I can take that table, I can move it into the living room, then I can move it into the kitchen, I can even move it outside the front door, but it is not going to change its shape. I heard someone else say that an apple and a computer were solids. Yes, you are right. You guys are so good at this. Now, I heard a few kindergartners say that water is a liquid. You're so smart. You can take that water, you can pour it in a glass, you can pour it in a bowl or in a pool, and it's going to take the shape of whatever you pour it into. Liquids are very cooperative. So, solids do not change their shape, but liquids can flow and pour, and they do change shapes. Now, how many of you have been eating a whole lot this break? I know that when I Zoom with my kindergartners, they've been talking about, and their parents have been talking about, that they're eating every 2 hours. So that makes me think of cafeteria items. So let's look at these items. And I'm going to get you to think here in just a little bit. These are items that you have in the cafeteria. You have things like orange juice, apple juice, milk. We often have cheeseburgers on Friday. We have chicken strips, and my kids love pizza. So, knowing what you know from last week about solids and liquids, I want you to sort or to tell someone right now which one of those things, which one of those items are solids and which of the items are liquids. Okay, I'm allowing you think time and share time right now. Sorting these into 2 groups. Okay. This is how I've sorted. You see the red word? That word is solids. I said that the pizza, cheeseburger, and chicken strips were solids. They do not change shapes. Now, can I pour them? Can I take them and take that cheeseburger and pour it into something else? No. So they are solids. Now, I want you to look at the apple juice, the orange juice, and the milk. They are liquids because they can flow. they can pour. Now, I want you to close your eyes. I'm going to close my eyes. I want you to think of that orange juice. A lot of times at home, I may have that orange juice in a pitcher. So picture a pitcher with a handle, and then your adult or the adult in your family pours that into a small juice glass. Do you see it moving? Do you see that juice pouring? It's taking the shape of its container. It flows like a river or a stream, and juice, milk, and apple juice are called liquids. Okay, you can open your eyes now. Now, on to the cool topic that we're talking about today, and we're going to be working your brain. We're going to be making it sweating. We're going to be talking about, can heating these types of matter and cooling matter, can that cause a change in its state? To talk about that, we are going to talk about temperature, how hot or cold something is. When we talk about heating matter, we're talking about increasing the temperature. Do you see the thermometer there? Heating means that red dyed liquid is going to go up or higher. This is what would happen on a hot summer day. When we say cooling matter, that red dye is actually something called ethanol. That red dye will decrease or go down like it would on a cold winter day. Okay, boys and girls, I know that you recognize this picture. Many of you have celebrated your 6th birthday this year. Many of you are going to celebrate this summer, maybe even today, maybe tomorrow. So happy birthday to everyone. Your family may have bought you a cake. So they're going to light the candles using a hot flame, maybe a match, but that hot flame is fire. It's very hot. So as they sing happy birthday, they're going to tell you to make a wish, and they're going to be taking all these pictures. But what's going to be happening to that candle? It's very hot at the top of those 6 candles. So all of a sudden, you're going to notice that wax is flowing. It's moving. It's going down the candle. Now, when it reaches a cooler spot, it may turn back to a solid. It may go all the way down to your cake, which is also cooler, and it's going to change to a solid. Gosh, here you were thinking about eating that yummy cake while this cool change of matter occurred. Right here, you see that. I've blown up the candle so you can see that the wax is dripping. It has adhered to the side of the candle. That's because it cooled off. But it could also go to the very bottom where it cools off and land on your cool cake. Can heating matter cause a change in state? I see a hot sun. Summer is coming. So, if you have a popsicle, that is solid. At that moment, it's not changing shapes, but very quickly it can start to flow like a liquid. That's because of this hot sun. All of a sudden, you're eating that yummy popsicle and drips start to flow down your arm, down onto the pavement, on your shirt. So yes, heating matter can cause a change in state. So can cooling or freezing matter cause a change in state? I remember when I was a little girl, I loved orange Kool-Aid. And so my mom would mix sugar and I guess the orange flavoring came in a powder, and then water, and she would make Kool-Aid. Now, Kool-Aid is a liquid. You see it in the pitcher with the handle. It flows. It pours. It changes its shape depending on what you pour it into. So we have a liquid. So can we cool that liquid or freeze it and make it change states? And you can see the popsicles. What my mom would do is she would take that liquid, that Kool-Aid liquid, she would pour it in this Tupperware popsicle set, and then she would stick it in the freezer. I don't know how long it took, but it was a nice treat on a summer's day. So, can cooling matter cause a change in state? That's what we were just talking about. Kool-Aid, it could be water. If we take that water, and you can see, that's actually my hand in that pitcher, but my hand is pouring water into an ice tray. Do you see that movement there from the glass to the ice tray? If I take that and I put that in the freezer, then all of a sudden, hours later, I have ice cubes. And those ice cubes are a solid. They are not going to change their shape as long as they're sitting there in the freezer. But there's more you should know. You can take those solid ice cubes and you can change them back to a liquid. The ice cubes just sit outside and they just stay a solid. I want you to think about this. Think of ways that we can take those solid ice cubes and we can make them move and pour and change into a liquid. You can think now, or you can share with someone, an adult that is with you, or a little sister, or your pet. I heard your conversations. You guys are so good at this. You are states of matter pros. I was also thinking, could you take the ice cubes outside to sunbathe in the hot sun? Could you hold the ice cubes in your warm hand and cause them to melt, to turn to a liquid? Could you place them in a heated skillet? So, can I turn ice to a liquid in those ways? Yes, yes, yes. By adding heat or warmth to the ice, which is a solid, you can change it into water, which is a liquid. And you can see, you have pictures of what we were just talking about. In the first picture, yeah, I took it outside. You see that water flowing. In the second picture, that ice is on my hand, on your hand, and it's melting. It's turning to liquid, and it's even dripping. In the third picture, that's my skillet, and I turned on the gas, and very quickly it was melting. It was changing to a liquid. Heating and cooling matter can change its state. This summer, I want you to be a nature spy. I want you to look around for matter changing states. Now, as far as the student response sheet, I'm going to go over that with you. I want you to think of different examples. I've thought of different examples and I put them on the sheet. For example, I thought of ice cream. especially going into the summer. If I take ice cream and I add heat, what's going to happen? Is that going to change to a solid or a liquid? You're going to circle. S for solid, L for liquid. Okay, if I have those freezer pops right now in the picture, it's a liquid. I just bought them at Sam's. They're a liquid. So if I put those in a freezer, what's going to happen? Are they going to turn to a solid or to a liquid? Circle your answer. There's a pond. If I add coldness, or actually coldness comes to the pond, meaning the temperature on the thermometer drops. Remember that red dot? It's going to go down, down, down. Brr. If you have that pond on a cold, cold winter day where the temperature is below freezing, below 32, what's going to happen over time, over many days? Is it going to turn to a solid or to a liquid? A snowman. It's in a solid form. It's snow. It's packed ice. If you add sun to that, what's going to happen? Is it going to stay a solid or is it going to turn to a liquid? Another part of that student response sheet is going to ask you, as you go about your day, do you see any changes in state? Also, if you can just think of one in your head without even seeing it, you're going to draw that in the box. And last, on the student response sheet, I have a poem for you. I love poems. I made myself a snowball as perfect as could be. I thought I'd keep it as a pet and let it sleep with me. I made it some pajamas and a pillow for its head. Then last night it ran away, but first it wet the bed. So, did that snowball run away? What happened? Why did the little boy think he wet the bed? Things for you to think about, and I want you to explain that to an adult as well. I want you to have a wonderful summer. It was great teaching you about states of matter, and I hope you have an awesome first grade year. I know that you are so good at solids and liquids, and you are going to be science pros. Your teacher, your first grade teacher, is going to be so impressed with you. Take care. Bye-bye.